Good afternoon and welcome to the ESAB Specialty Alloys live event. My name is Clemente Talarico, and with me as the presenters we have Mr. Peter Stones and Mr. Richard Craig, as well Per Åke Bjornstedt for technical support. I'm pleased to announce here the 9th presentation of ESAB Specialty Alloys, which will happen every third Friday of the month at 14:30 European time by a team live event. The 9th presentation of the program will be the one starting in few seconds with the title, How does filler wire quality affects welding performance? We will be very happy to answer your questions at the end of the presentation, which you can type in the Q&A box you will find on the top right of your screen. We intend to present on about 30 minutes and take 10 to 15 minutes more for answering your questions. And now let us start the show with Peter and Richard presenting. Enjoy.
Thank you, Clemente, and good afternoon, everyone. Thank you for joining us. As Clemente said, we intend to talk for about 30 minutes with the presentation. You don't have to take notes because we're more than happy to supply you with copies of the slides. Both myself, Richard and Clemente's contact details are available at the end of the presentation. Please feel free to email us or call us if you have any questions, any queries about anything that we're talking about, or indeed anything to do with specialty alloys. We'll be more than happy to help. So, how does filler wire quality affect welding performance? What we're trying to do is get a good weld every time consistently. And what helps with that? So the topics that I'll be talking about are specifically the importance of a consistent composition. So is it the same every time? The same with dimensional stability. So the diameter, the cast, the helix, the hardness even. How do they affect the weld quality? Surface finish and coatings are fairly obvious ones. Some people prefer dull, some people prefer shiny. The amount of the cleanliness of the wire can obviously affect the weld performance. So, talking about the composition, not going into too much detail, but this is typically the elements that you would see on a 3.1 certificate for something like a duplex stainless steel. Chrome, nickel, moly, all of these elements have a different effect on the properties of the weld metal. As I said, those are the type of things that you'd see in a 3.1 certificate. However, what you may not realise that for in AWS, the specification is quite broad and quite wide. So for something like a 316L stainless steel, austenitic stainless steel, the range of chromium is between 18 and 20%. I mean, it's quite a big variation, together with a nickel range of 11 to 14%. So the alloy that you get that's got 18% chrome, 11% nickel, has going to have totally different properties, well, different properties anyway, in terms of corrosion resistance, from one that's got 20% chromium and 14% nickel. So it's something to watch out for. That you may not be getting the properties that you would normally expect. And certainly if you've been used to using an alloy that's got the percentages at the top of the scale, and then suddenly you get one that's at the bottom of the scale, then the properties will be different, and you may think that you've failed in some way by your procedure or whatever, and it could be purely the filler metal. But just as important as the composition, obviously you want to be at the higher end of the scale to get the better properties, but more importantly with something like robotic production, is that it's the same every time. So you want the arc to react in exactly the same way between coils, between spools, between lot numbers. So if you've got a robotic process that's going hands-free for hours and hours and hours, you don't want to change the spool and have to change the parameters. So this is it's more important with automatic robotic production than manual. Obviously the welder compensates, but still, if there's a massive range, then the welder's going to have to compensate a lot. Something I would mention about the better quality filler metals are these things called microelements. So microelement alloys are added to various alloys to basically to improve the performance. We call them microelements alloys because they're tiny. They're down to 0.005%. So they wouldn't appear on your 3.1 certificate. So these are the little magic dust, if you like, that improve the properties of the weld metal in terms of spatter. Obviously, the less spatter, the better. The less grinding, more welding that you're doing is obviously better. Fluidity of the weld pool as well. These microelements have been developed specifically to help that kind of thing as well. The more chromium, nickel, molybdenum that you put into an alloy, the less fluid the weld pool is. And so to help that, to make it easier to weld, to make sure you've got a flow into or the root gaps and things, make sure you've got no lack of fusion, then an improvement in the fluidity of the weld pool is a big improvement, and these things do it. Deposition rate is another good one as well. If you can improve the deposition rate, get the same quality and actually deposit more, then you're going to improve your productivity. So talking about mechanical dimensions, stability, surface finish. So how the surface finish affects the wire feed. Now, ESAB's got a state-of-the-art wire mill in the Czech Republic, and the consistency is ensured by virtue of us drawing the last diameters drawn through diamond dies. So these are very, very stable, very hard, last a long time. So you know that at the beginning of the spool, the diameter is going to be the same at the end of the spool to within 0.0001 millimeter. Okay, not everybody does the same. If you don't use diamond dies or some kind of spinning dies, rotating dies, then there's a possibility that you're going to get wear in there to some extent. And if that doesn't get noticed, then you get a different diameter. Okay. The drawing and annealing sequence, obviously, as you're drawing the wire's getting smaller, it gets harder. So you can't just have a solid, really brittle, hard wire at the end, because that's no good to anybody. So it's got to be annealed somehow. So there's a sequence of drawing, annealing to make sure that at the end, when it is being spooled, it's exactly the right toughness, ductility, hardness. Okay, and again, we've got a state-of-the-art mill to make sure that happens. If that's not consistent, again, if there's if it's not a rigid as procedure that ESAB have, then there's a possibility that the hardness, the ductility could vary and could change, and certainly could vary between lots. In terms of coating and lubricants, all wires are supplied with a coating. Unless there's some real special pharmaceutical applications, then the wire is generally not supplied squeaky clean. It's not completely clean. If it was, then you'd have difficulty feeding it through the liners and through the conduits on your machine. So the reason that there is a lubricant on there is to aid that. What you don't want is too much, and what you don't want is patches where it's thicker and thinner on the surface. So consistency is what we're talking about. This is an illustration of the surface finish effects of the wire. So this graph is plotting the power, the amount of amps taken by the drive rollers on a wire feed unit. Okay. What you can see, notice, the average amount of current required is quite high, and there's a lot of spikes. There's a lot of variation. So that means that the surface finish of this is taking a lot of power, less power, a lot of power. So the surface finish varies across that. So it's inconsistent. So you're not going to get a nice, smooth, consistent feeding. If you compare it to this graph, which is an ESAB wire, exactly the same parameters. It's a 20-minute feed test, and it's what we do for every batch. The 20-minute feed test, you can see the whole power usage is lower. The average is certainly lower than previous. and the spikes are not so high. It's more constant, it's more even. That means you're going to get a better, more consistent feeding. This helps. Cast and helix. Cast and helix are terms that are used particularly for spooled wire. And again, what you want from a spool of wire is that at the beginning of the spool, at the end of the spool, and the next spool and the next lot, that this helix and the cast is the same. So the helix is the distance. If you cut off a couple of meters of wire, hang it from something, a pencil, your finger, whatever, then the distance between the two coils is the helix. Now we have a maximum of 25 millimeters, but the smaller the better, basically. And again, it's better if it's the same. It doesn't matter if it's 25 millimeters, it doesn't matter if it's 0, but if it's always 0 or always 25 millimeters, that will help. Similarly, there's obviously a twist, there's some tension put into this wire to enable it to come off the spool, and that puts a cast in it. So you throw the 2 meters of wire on the floor and it will naturally form a circle. The diameter of that circle is what we call the cast, and again, we've got it's roughly 1 meter. That's what we're looking to achieve. And the reason is that as the wire's been fed through this MIG torch here, as the wire's been fed through here, you want it to hit the workpiece at exactly the same point every time. If there's variations in the cast and the helix, then there's a chance that this is going to vary. And again, it's not so much of a problem with manual welding because the welder can compensate, but he shouldn't have to. But if you've got automatic welding, then it is quite important. And certainly for an auto TIG, I'm sorry, I've only got a diagram of manual TIG here, but the principle obviously is exactly the same. You're pushing the filler metal into the same place. If for whatever reason the cast of the helix of the metal changes, then the end of this filler rod is going to vary. So it's going to enter a different position of the arc. So the weld is by definition going to be different. It's not going to enter at the optimum position where you want the filler metal to enter the arc. Again, consistency. The more consistent the wire, then the better the weld will be. On something like a marathon pack, it's slightly different. Then basically, it's wound with tension in it to enable it to be fed out of the pack in essentially a straight line. What you're trying to look for is a straight line, but we have rules. What comes out is gently a wire that has an amplitude, so it's got a nice waveform there. And again, you'd measure the amplitude of the wave, and you want that to be consistent from the front of the pack to the end of the pack, and the next pack and the next lot. And the cast on this is basically the height. If it springs up from the floor, then it's the height of the spring. And again, consistency. So it's exactly the same effect. Whether you're feeding these machines from 15 kilo spools or a bulk pack, you're after consistency, and it's quite important, and it will affect the quality of your weld. In terms of cleanliness, I've got a couple of slides just to illustrate the differences between a clean product and a not so clean product. What we have here is a 625. You can see the TIG rod here being fed into the arc, and the surface of the weld pool is so clean that you can actually see the reflection. You can see the shadow reflection of the, well, not the reflection, the shadow of the TIG rod onto the weld pool. On a competitor's product here, we see there are oxides. I'll not say slag, but certainly oxides in there, and so you can't get the same effect. You can't get the same effect. You don't have the mirror finish to enable that to be seen. And the last slide that I have is showing this welding of a tie. If you've got a buildup of black soot, oxides, lubricant on the surface of the wire, then you end up with a very big black scaly oxide pool. And essentially, this is we don't get that essentially, but this will absolutely illustrate it. Okay, so you know what we're trying to say what I've been trying to put across is the importance of the good quality wire that's got a good composition with good mechanical properties, and the surface finish, the tension, the dimensions are consistent. If they're consistent, then you get more of a chance of getting a good quality and consistent weld. So thank you for listening on that, and I'll pass you over to my colleague Richard, the UK sales manager, who is going to introduce to another essential part to enable consistent welds is what he's going to talk about now. So Richard, over to you.
Thank you very much, Peter. Yes, so I'm going to talk to you all this afternoon about the benefits of RobustFeed, which obviously, when combined with the qualities of the wire that Peter has described, should give you almost perfect welding. A high quality wire is important to ensure consistent welding, but also an important component of any MAG system is the wire feed system. It's also the most vulnerable part, and it's often subjected to a harsh environment and is often exposed to potential accidental damage. One potential solution is RobustFeed. Okay. Okay, so you can see from the video, the RobustFeed is highly portable. It's got 3 ergonomically designed handles to enable safe lifting and can be passed through small gaps in say, in the bottom of a ship, etc. The wire feed unit can be used in 2 positions, 1 upright and 2 in the flat position. And all we have to do is simply rotate the control panel through 90 degrees. It has a rugged strain relief mechanism that protects the internal cables. That's the control cable, the power cable, the gas cable from any strain. So you can actually suspend this by its umbilical on the locking mechanism on the right hand side of this slide without any damage at all being caused. Sometimes to get the wire feed unit onto the spigot on top of a trolley, it can be difficult. So on the RobustFeed, we put a slot at the bottom. So you simply locate the spigot on the slot, slide along, and it drops straight into the hole. We have a brand new wire feed system, which is exceptionally powerful and precise. And it's also got an integrated heater and flow gauge inside the wire feed unit itself. We require no tools to change any of the components on the wire feed system. Both the inlet guides, wire rolls, they can all be done without any tools at all. We have a wear parts storage system, which is integrated into the lid of the wire feed. And here you can store your contact tips, your wire guides, your feed rolls. It has a rainproof housing. It's rated IP44, which is probably the only one on the market actually that is rated IP44, even when it's on the flat on the flat ground. RobustFeed can operate at temperatures as low as -40. But as I said before, we have an integrated heater system inside the RobustFeed, which enables it to have its own microclimate so it protects the wire. It's easy to operate in dark environments. It's got large backlit displays, an illuminated wire feed system, and an illuminated area for the wire also, so you can actually see when you're putting the wire onto the spool. We also have lights on we have a window so you can actually see through onto the wire, which is also illuminated. We also have an integrated USB slot. This USB slot can give you software updates to the wire feed system. It can operate as an arc time counter, and it can also charge a mobile phone. So just a quick overview of the RobustFeed. It's robust and reliable. It has a strong and precise wire drive system. It's highly portable, mobile and maneuverable. It's safe for crane lifting. It's rainproof in vertical and horizontal positions. It operates in dark environments with lights inside and backlit symbols. It's multifunctional. We have many accessories to go with it. It's externally insulated and short circuit protected. It has integrated wear parts storage, and its operating temperature is from -40 to +55 degrees C. Any questions?
Thank you, Richard and Peter. Well received. As well, thank you all for your participation and the good questions highlighted. So the first question that I see on the field, I see, what is the smallest mild steel wire that RobustFeed can cope with?
The smallest diameter it can cope with is 0.6 millimeters.
All right. Okay, so this is the smallest one, 0.6. All right. The next question comes to the first part of the presentation, and it is, what are the micro-alloying elements? What are they? Peter Parocchi.
Do you want that, Parocchi, or shall I?
Go ahead, sir.
I knew you'd say that. The micro elements. This is the proprietary secrets, if you like, of the metal manufacturers. So the exact details of exactly what they are in exactly which grade are a closely guarded secret. However, I can tell you that things like sulfur, believe it or not, so we normally see sulfur as something bad, but sulfur down to 0.0005% has an effect on arc stability in some grades. Not in every grade, but in some grades. Oxygen to a similar sort of percentage, oxygen in some of the nickel alloys will have a similar effect. Silicon, boron, they're also the types of elements that are used. It's again, these things exist, but you can't give the secrets away. Hope that helps.
All right, thank you, Peter. We have another question in the chat box, and that's saying, thank you for your presentation. Thank you to listen and to participate. We are using ESAB wire, nickel chrome moly 3, in diameter 2.4 for submerged arc welding process. The wire is pushed through a 3-meter lens and then through a very curved contact tip. Depending on the batch number, we are facing blocking in the contact tip. For other batches, everything goes well. Do you have a suggestion of tests to perform or the wire evaluate his ability to the feed property?
Go on, Perok, I'll let you take that one.
So, well, there are different approaches here. It could be so that the tensile could vary if you're unlucky. It's very uncommon, but that could be one thing. We are keeping track of the tensile quite thoroughly because we know that it affects the wire and the feedability of going through the contact tip and causing, for example, more wear on the contact tip. So that needs to be considered. The other thing is that what Peter mentioned in his presentation, and that is to measure the cost of the wire.
Yeah, I can put that back on the screen. It's a good indication of the consistency between batches. If you cut off a couple of meter length from the spool, and we're talking straight from the spool rather than through any guides or anything, then you'll know that the guides have not had any effect on it. Cut a couple of meters off and throw it on the floor, and you'll see the diameter that it forms naturally and the distance between. So the diameter will be the cast and the distance between is the helix, as I said. If that's not easy, then you can literally hang it from something, anything. So it's just free hanging in space. And again, it'll form a cast naturally, and there'll be a gap or not between it. And really, a check would be to see, is there any difference between the spools that are working successfully and the spools that are not? Check the cast and the helix. That's a quick check, just to see whether something's varied. That's before you have to go into any kind of metallurgical investigation or hardness tensile checks. Okay.
All right. Thank you, Peter, for that. But I would like also to add on that is that if you have such kind of indication, please don't hesitate to contact Peter or myself.
No,
and
indeed.
Then we will take it really in deeper on that regards. But the first thing is really to check the cast and the helix, and that goes for all kind of wire products which are on spools or on bulk pack like marathon pack.
On the marathon pack, it's different. It's the same type of thing. Cut off a couple of meters and throw it on the floor. And what you're trying to see is it as straight as possible and with not so much bending off the floor. So.
Sorry, what I would like to add here is that the guy who is putting the question here, he says that it is going through a very curved contact tip. And we have seen some applications before, and we do have some measures that we can take to encounter, and that is we can make the wire softer by a special treatment. So but that will be a special request for certain applications. So that can be arranged as well.
Yeah, I'm just interested why it has to go through this curved contact tip.
Yeah.
You know, is there a reason? Is it some access?
Yeah, could be
difficulty, whatever. So, if it has to be, then it has to be, and we could probably work around it. But can we engineer out the curved contact tip?
Yes.
Yeah.
So really get in contact with us. We would like to understand and see
Yeah,
that a little bit,
very much.
bring a solution up on that. All right, good. I go to the next one, and in principle it's quite the same, so we don't need to bring a lot of answer here. Is it possible for the cast and helix of a 15 kilograms spool to be measured on site? Peter.
Yes, there you go. Exactly what I said. Just chop off a couple of meters and throw it on the floor.
Yeah.
And then you get your answer.
Yes, very easy to see.
Yeah.
The next question goes to Richard, and it's what is the duty cycle of a RobustFeed at 500 amperes?
It's 60%. And it's 400 amp, it's 100%.
All right. Good. All right. So I see also that the person who put the questions regarding the wire and the wire feeding, yes, it is due to a very narrow access. So coming back to the question before.
Right. Okay.
And thank you for
thanks for
the
answering
question, putting up this question. It was very interesting to discuss that. So please get in contact with us. All right. I don't see more questions popping up, coming up. So as we said, please note down Peter's and as well Richard and my contact details. Peter, you maybe can show the slide with our contacts. Yeah, from the screen, which Peter are bringing up now. We are already now very happy to answer your future questions and the further questions. It's a really pleasure to be supportive for our customers. And yeah, with that said, we wish you a successful rest of the day and see you soon in the next live event in 1 month before Christmas.
Thank you. Have a good weekend, guys.
Thank you.
Thank you. Bye-bye.
Bye-bye.